Now let's look at some functions and find where they continuous at. So let's discuss the continuity of each function. So we're going to start with the function f of x equals 1 over x. And let's start by talking about what's the domain of this function. So if I asked you for the domain, what would the domain be? Well, what can't I plug in for x? There's one number I can't plug in for x, and that's 0. So the domain here would be everything but 0. So in interval notation, negative infinity to 0 and 0 to infinity. If I'm looking at any other number other than 0, so if c is not 0, when I take this limit of my function, 1 over x, this is a rational function. The denominator is not 0, so we learned we can just plug in. This is 1 over c. And that's the same thing I get when I plug in c into my function. So note that these two things here, 1 over c, these are equal. And so I know that my function is continuous everywhere except for 0. So this function is continuous at every real number except 0. And if you graphed this function, you would see that this was true. So let me go ahead and sketch out a quick graph of this function. So the graph would look like this here. And then this here. Okay. So if I look everywhere except 0, when I'm drawing the graph, I never pick up my pencil, but what happens at 0 is I have to pick up my pencil to draw this second part. So here I would not, my function is not continuous at 0, and I could also say that it has a non-removable discontinuity. Let's look at another one, another function. So let's look at the function g of x will be x squared minus 1 over x minus 1. Again, we're going to start by asking what is the domain of this function. What's the domain? What can't I plug in for x? I cannot plug in 1. So my domain would be negative infinity to 1 and then 1 to infinity. And if we, let's just go ahead and graph this function. If we graph this function in your calculator or on a program, you're going to see that it looks like a line, but at 1, I have a hole in my graph. So my graph will look like that. So again, when I'm drawing this graph, I draw it out. I have to pick up my pencil at x equals 1. So here, this graph is, or this function, it's continuous for every real number except 1. And here, this would, at x equals 1, it would be a removable discontinuity because I just have a hole there in my picture, my graph. Let's look at our next function, which would be h of x. It's going to be a piecewise function. It'll be x plus 1 if x is less than or equal to 0, and e to the x if x is greater than 0. So you can draw the graph of this piecewise function here. So I'm going to start with the first piece. This, if it's less than or equal to 0, it's this line here. So at 0, it's 1. -1, it's 0. And then this is a line, so it'll go out like that. And then e to the x, if I plug in 0, I get 1. So it starts at this point here. And then I'm going to go at 1. It's going to spit out e, which is between 2 and 3. So it looks something like that. So now let's look at our picture here. Really, this function is made up of a line. This first function here is a line. That's going to be continuous. And then e to the x is also continuous. But then I've got to worry right here at this point where I switch between functions. Is that continuous? So if I look at the limit as x goes to 0 of h of x, what would the limit be? Well, as I approach on the left, I get 1. As I approach now from the right, I also get 1. So the limit would be 1. And what is h of 0 equal to? H of 0, if I plug in 0 into my function, I get 1. And look there, these two pieces, these are equal, and that's exactly what it means to be continuous. So our function is continuous at x equals 0. So that means it's going to be continuous everywhere. So this function is continuous everywhere, i.e., it's continuous on the interval -infinity to infinity. So the last one we're going to look at is this function y equals sine of x. What's the domain of this function? The domain is -infinity to infinity. And so what you should do next is you should graph this function. I'm not going to do that here, but if you graph it, you will see that this function is continuous everywhere as well. So -infinity to infinity.